Hey, welcome to The Explainer. Today, we're putting AI on the stand. We're going to tackle a huge question for anyone in this field, and we're taking our cues from some of the core challenges in the AWS AI Practitioner exam. And that question is, how do you actually prove your AI is any good?
So let's just dive right in. Picture this. You've spent weeks, maybe months, building this super sophisticated AI model. It feels like it's working, right? But, a gut feeling doesn't exactly fly when you're talking business impact. So how do you go from, I think this works, to having real, hard numbers that prove its value? That's exactly what we're breaking down today.
First up, let's talk about language. Language models are everywhere now. Translation, chatbots, you name it. But how do we grade them? How do we know if they're actually fluent or just faking it? Getting this right is a core skill for any AI pro, and it's definitely something a platform like AWS wants you to master. Okay, so here's our first case study. And this is a classic problem you'd see on something like the AWS exam. A company's using a large language model, an LLM, to translate their training manuals. The goal is pretty straightforward. Figure out if the translation is any good. But how do you score a sentence? It's not like a math problem that's just right or wrong.
And the answer, the right tool for this job, is the BLUE score. The name stands for Bilingual Evaluation Understudy, which is a mouthful, I know. But the idea is actually pretty brilliant. It just compares the machine's translation to a bunch of high-quality translations done by actual humans. The closer the machine gets to what the pros wrote, the higher its BLUE score. Simple as that. Now, a big part of understanding why something is right, especially on an exam, is knowing why the other options are wrong. And in this case, the other metrics just don't fit. You wouldn't use RMSE, because that's for predicting numbers, like house prices. The F1 score? That's for sorting things into buckets, like spam or not spam. And then there's ROUG, which, well, it's a close cousin to BLUE, but it's built for a totally different job. And this slide just lays it out perfectly, right? BLUE is all about precision. It asks how much of what the machine wrote word for word matches the human translation. It's all about faithfulness. Rouge, on the other hand, is about recall. It's for summaries, and it asks how much of the original important information did the machine manage to capture. Two very similar sounding tools, but for two completely different language tests.
All right, let's shift gears. We've handled the tricky, nuanced world of language. Now let's switch to something that feels a bit more black and white, classification. This is where the AI has to make a clear choice, and we really need to know if it got it right.
So here's our next scenario. Again, straight from the kind of problems you'll see in the wild. We've got an AI model, and its job is to look at pictures of plant leaves and spot diseases. The stakes are pretty clear here. Is it correctly flagging the sick plants, or is it letting them slip by? The big question is, how good is it at its job? How do we even grade that?
Okay, so the first thing that probably jumps into your mind is just accuracy. And it is exactly what it sounds like. What percentage of the time did the model get the right answer? If it looks at 100 leaves and gets 95 of them right, either healthy or diseased, then its accuracy is 95%. It's simple, it's clean, and honestly, it's a great place to start.
But is correct really the whole story? Think about it. What if missing just one diseased plant could wipe out an entire crop? That's a huge problem. Or on the flip side, what if flagging a healthy plant as sick causes a farmer to use a ton of expensive pesticides they didn't even need? In situations where the stakes are high, just being correct most of the time is nowhere near good enough.
And that's where we have to get a little more sophisticated and bring in two superstar metrics, precision and recall. Think of it this way. Precision is your false alarm detector. It asks, of all the times we screamed diseased, how often were we actually right? And then you have recall, which is your don't miss anything important safety net. It asks, of all the plants that were truly sick, how many did we actually manage to find?
So you see the problem, right? If you focus too much on precision, you might miss some real diseases. Focus too much on recall, and you're crying wolf all the time. You need balance. And that, my friends, is where the F1 score comes in to save the day. It's this one elegant number that perfectly balances precision and recall. It's your go-to metric when both kinds of mistakes are really, really costly. And that's exactly why AI practitioners are expected to know it. Okay, so your model is a rock star. It's accurate, it's balanced. But is it actually practical? Can we afford to run it? Is it fast enough to be useful in the real world? This is where our technical wizardry meets the cold, hard reality of business.
First up, let's talk speed. An exam question might ask how you measure a model's runtime efficiency. And the answer couldn't be simpler. Average response time. Basically, you hit go, how long to get an answer? That's its real-world speed.
But when we're talking about today's huge generative AI models, there's another cost that's often even more important than time, and that's tokens. A token is the basic unit an AI thinks in. It might be a word, or just part of a word, like ing. So that big report you're feeding it, the AI doesn't see pages. It sees like 75,000 little pieces called tokens.
And this is the kicker. This is what you absolutely have to know. In the world of generative AI on services like Amazon Bedrock, you're not paying for how long the model runs. You're paying for how many tokens it processes. Every prompt you send and every answer you get back, every single one of those tokens has a price tag attached.
Okay, wow. We've been on quite a journey, right? We went from the nuances of translation with Blue to the life or death classification of the F1 score, and now into the business realities of speed and cost. Each problem needed a different weapon, so let's put our whole toolkit on the table and see what we've got.
And looking at this, the big picture becomes super clear. There's no one-size-fits-all, no single best metric to rule them all. Evaluating AI is not a simple problem. The real skill, the thing that separates the pros, is understanding the goal and then picking the perfect tool from this toolkit for that specific job.
And that brings us to our final and maybe most important question. Your metrics can look fantastic on paper, but what really matters? Does the customer, the end user, agree? Because at the end of the day, all these numbers are just tools to help us build something great. The ultimate test of success isn't a score. It's the real value it brings to a real person.